Cool. We'll give it one more minute here. Awesome. So why don't we hop in? So Voyager, first of all, let me actually, there's like some good videos. So let me go to this. So Voyager is essentially an RL agent that has to work its way through Minecraft. And Minecraft being this world that's fairly open-ended. Have you? I actually haven't played Minecraft much. Have you?
This is where the three of us admit that there's not a single Minecraft player here. So I've gone deep down the rabbit hole watching people build redstone computers. So I
feel like though a lot of LLM papers, I don't know if you guys feel it, have something to do with video games. So like I think being a gamer is an advantage if you're into the LLM world.
Yeah, I think so too. Either way, there's this game seems to pop up a lot in RL. And I think it's because it's so open-ended. It's not like you're, level by level, the traditional games we grew up with. It's build a world, and it becomes challenging when things are open-ended because there's a lot of different things you can do, a lot of different things you can explore, a lot of things you can build. And apparently, as part of this game, one of the hardest things to do is, I guess, achieve the diamond, which this did do. But kind of I think this was like done in a pretty amazing way. We'll talk a bit about the paper in a second. Using essentially GPT-4 to come up with a curriculum that explores kind of that gives an exploration of the space, a set of actions and things it should go do. Based on completing those things it should go do, it builds skills. So skill library of executable code, which I actually think this is one of the more interesting things here. If you kind of go through the paper, if you go through the paper, like they attach, later on they'll attach it to GPT-4, the same, Auto GPT, the same skill library, which is a different, which is a different kind of RL approach. And it even improves Auto GPT. So the skill library is one of the most interesting things here. I think we'll spend some time on that in talking about like, where does that space go? Probably also ties into OpenAI's latest release of information, latest tie into functions and code. And then there's basically an iterative approach to the prompting, which incorporates feedback. So it like builds these skills based upon execution and improves them based upon the feedback from the environment. Anything else to add as we go in?
It's a pretty good summary of the technique. I think the ablation studies that they go into at the end, which you referred to a moment ago, are pretty interesting. But yeah, let's get into it.
Yeah,
let's get into it, because I feel like there's the skills. There's also like, what are the impacts? But like, what can you do taking the techniques from this paper, and what does it extract to code generation? That's really interesting. That I feel like all of Twitter's been talking about. So that's a fun one.
Love it. I think that's exactly it. And like this last sentence here, like the lifelong learning thing is probably the biggest tie into the code, where we all are used to building skills and talents, and hopefully they're reusable, and hopefully I can use I can build on the talents I have to do other things. But LLMs don't have that. And I think what's also interesting is in the traditional model approach to build skills, it's a gradient, like they hinted here, it's a gradient based approach, like you're training something to build some skill in some area, where none of this is training at all, none of this is fine tuning, it's all prompts and uses of GPT-4, and to get these long-term skills you use code. It's pretty kind of amazing approach to building the skill sets. And it kind of gets at this, like, there's an argument here for lifelong learning or building these skills, are coming up with those tasks, like what skills do I need? Refining those skills based upon feedback. So I go try to attempt something and I either am successful or not at it, or there's some grading of it. And then exploring to figure out like what new tasks do I need to go do? Like, do I run into a river or a mountain, or like what is it that I actually need to do, and figure out new tasks to go build on top of the skills I have. I think it's a pretty good argument for what as a lifelong learning approach. I'm sure over time, fast forward 4 or 5 years, we'll get more complicated in this area, but like it seems like a pretty good breakdown of a simple approach to gaining and building kind of skills that we have. Anything else y'all would add?
I think, could we jump into maybe the first, like each part of the method? So there's kind of the curriculum, generate the automatic curriculum component. There's the building a skill library, and then there's kind of that iterative prompting mechanism.
Yeah.
The part that was, maybe we can jump into each one of these components of the 3 components. So the part that I was really trying to take away from the skill library made sense. Okay, once you have a skill that you've learned, you can add it, you can do a search on it later on where to use it. The automatic curriculum, this one was like, how do you generate that? And how, like maybe we could dive into a little bit of that. Like, how do you know?
That was the fascinating part. They actually discuss the difference between a random curriculum and a manual curriculum versus the automatic curriculum. I kind of came away from the paper thinking about curriculum like coaching. And it was really interesting in their ablation studies later, when you remove an automatic curriculum, basically the agents get stuck without really knowing what to do next. So just this process of prodding and directed prodding based on the outputs of previous tasks. So did you succeed, and the kind of progressive overload of your agent in order to make it stronger and stronger and actually gain new skills.
Yeah.
How do you guys think it was just through the prompt engineering of asking it to, knows the agent's state and knows what it's completed and what it's filled out before? Like how, I think.
So prior, the other day, just while I was reading the paper, I was curious to see like what amount of Minecraft information GPT had encoded in its parameters. So I asked it kind of a weak version of their initial input prompt. So I said, what's the best strategy for playing Minecraft if I want to discover as many diverse things as possible? Which is kind of as many diverse things as possible from their paper. And it has a solid understanding of the game, the way it works, specificities of the environments that you might encounter, different creatures that you would find there, the different material types. Again, I don't play it, so it could be lying to me, but it appears to know quite a bit, to quote the RAG paper, in its parametric memory, even without kind of these learned non-parametric skills. And so I think just based on what it's learned from the internet, it knows enough about Minecraft that if you say like, I'm in the forest with these materials, what should I do next? Yeah. You'll get a semi-meaningful response. And if you compose a more sophisticated prompt, it makes sense that you would get an even more detailed suggestion of what to do next.
Yeah, I think that was a good point. When I was reading this section, like I was thinking, basically what we're saying is it has kind of a worldview of Minecraft. Like it's got an idea of that entire Minecraft world. It's got an idea of what it, maybe what it should be doing, or what the task could be to do your next thing. So it's trained on enough data to have a view of the world, to then even espouse an idea of tasks. Like I was kind of thinking that myself, but I think, Michael, you're kind of the little test you did kind of proves it a bit.
An example is like gather resources. They're pretty general. Gather resources, collect a wide range of resources during your exploration. So I was curious. I imagine it's the additional context, like the current state, that gets you specific answers.
Yeah.
And I think it was interesting here where like the focus was really on the diverse behaviors over just mining a diamond. Like that was really interesting that the focus was on, collecting as many skills as possible.
Yeah. I think, I guess one question too, as you think about generalization of this to other things, like, would it work in a place or a game where it didn't have the same, extensive worldview, like a new game, for example? Are you, how much does this generalize across? How much could it generate the tasks to go do if it doesn't know totally about this game or environment?
I think that's an interesting question, and it leads into the skill library. And
Yeah.
I guess I'm still primed from last week's rag paper reading, but the extent to which this feels like many search and retrieval problems embedded or composed together. Like you could take the skill library and its prompt or query and passage into the context of the next prompt as a mini search and retrieval problem. And to get to your previous question, if you had, if I wrote a game today that GPT-4 didn't know anything about, could I not write extensive documentation for this game and build a search and retrieval engine which functioned as my automatic curriculum? And so I see this search and retrieval like a module that you can plug that technique in. And I kind of think that's what they've done with the skill library.
Yeah, I think this is probably the most interesting thing about the whole paper in my mind. And it wasn't even the search and retrieval approach to me. It was like, man, like building knowledge is about building code that's executable, and building a hierarchy of code that you can go execute is kind of your maybe it's skills or abilities, but maybe it's not knowledge, it's skills and abilities. It's the ability to kind of use data to go take actions or do things. But that is quite powerful. And I saw there was a Twitter thread going on of like LMS shell, LMS core, like I kind of posted internally in the section. And I think it hints at a couple things there. Like it hints at like, is it like, is the code outside of everything and the LLM's just running and code's responding to it? Hints at also, is there different LLMs for kind of different agents in the end? I think, Michael, you had a comment that you thought this paper was a little of both anyway. It's a little line to draw.
I mean, I think absolutes are useful for defining a continuum, but it's rare that something is all one or the other. So this idea that you're going to have, you write the outer shell that interacts with an LLM, or the LLM is the entire outer shell producing this executable code. It seems to me that any real application is going to be a combination of the two. But using that as a framework for thinking about this paper, it's quite interesting that the code that the authors wrote is scaffolding. Nowhere are they writing code that encodes the logic of playing Minecraft well. The code that they've written is at best like knows about coaching maybe, and about how skills are built. It's scaffolding. It understands how to prompt an LLM, what to do with the outputs of that prompt, how to take that and execute executable outputs, and basically create this feedback loop. And all of the code which knows how to play Minecraft was automatically generated through sort of like a semi-reinforcement approach. I mean, we haven't got into it yet, but the iterative prompting is kind of an interesting, like, sort of reminds me of evolutionary algorithms, where you just kind of make something, see how it does. And
so there's iterative prompting. There's basically, we'll go into the kind of the feedback loop probably in a second too. There's like the whole critique of what you did. There's like components of that. I think in this case, I do think like like still harping on like code as saving skills and actions is like fascinating paradigm. And then you have like in conjunction, literally yesterday, OpenAI releasing an ability to run functions from the API calls, which you can imagine you could build skills within your client code base of functions to call, the skills that you have. And when that LLM responds, you run those skills that you have in your code base, you run. So like this whole paradigm, like noticed by OpenAI, they're already releasing stuff to support it. So you could run your own, you could build your own skill library of functions on your side that you would execute and start to store those. So
for those of us, you
Yeah.
know, before I jump into all the details of, there's actually a really good visual on the code core and the code shell that we should share from Twitter. But before we jump into that, just for the folks who are following the train of the paper. So you have this curriculum that you're building by asking, you know, you're asking to first teach you these diverse skills, and then generates code, and then you save off. So the skill library, what it's doing is it's taking basically the you know, if in this case you have craft an iron pickaxe in Minecraft, and so it, you know, has this code to basically tell you, I guess, response here, which is like to craft an iron pickaxe, like it tells you what you need to go do. And it doesn't have to be iron pickaxe. It could be, how do I go? I think there's a bunch of them, like, how do I go hunt or whatever? Tells you how to go do that based off of your current state, generates code for it, saves that off if it needs to be code even, and then saves that off in your skill library. So now it's kind of like, I don't know, like you're going to school, you're learning, I've learned today my skill for reading, maybe when you're younger, and then like later you have skills of like, you know, drawing, and I have learned, like you can build on top of each other. So in this case, they're getting more and more specific, right? There's like mining wood log and making a crafting table. And so you start building these skills, and then later when you're actually pulled into another task, you can look at your skill library and use those skills to go kind of build on top of that, and then add an even more complex skill into your skill library, which is, you know, maybe you start off by, I don't know, like you can start off by learning how to, I don't know, make a you know, chop wood, and then you can take the chop wood and then learn to like make a table from it. And so it's kind of like that's kind of what I feel like the skill library concept here was trying to get at, and that was really interesting. It was really freaking cool, actually.
yeah, I think it's a paradigm we're going to see a lot in the LLM space. I mean, it took me a minute to figure out like what the value was, I guess. But it's clear. I think it's clear there's going to be kind of a whole set of things built on top of this, especially with the latest OpenAI release.
I think similarly to the way we're seeing, you know, you bring your data to an LLM in the form of chat on your docs, or I know I keep coming up to search and retrieval as a tip, but it's just because I see it as such a valuable primitive. But this skill library, I think, is identical to this chat on your docs, but it's almost chat on your logic. Like you provide a standard library for interaction. In this case, GPT wrote it, but they can be function calls from anywhere. And, you know, GPT only wrote some of it. It is calling standard libraries that were probably written by measly humans. But this idea that you could bring your, it creates an interesting interface between the code that you want control over and the control that you want the language model to have. I think we're going to see a lot of really interesting uses of this. I think even outside of game playing. I think probably particularly outside of game playing.
I think
if all we have is a bunch of, you know, better Minecraft players, we're not doing the world good.
I think the after reading this, some of the questions I had around the skill library was, well, first, this, at least in the example above, in that example above, Jason, the
Yeah.
skills were pretty dang specific, right? So if I had to take this to the thing that I could think about most applicable is code generation, right? Like imagine if it could write code. First, you teach it how to write a simple application, and then it builds skills on top, like connect to a database, connect, et cetera. And you could kind of, build on top. So the first thing I was like, how does it know, how specific does it have to be to call it, a skill? Versus how general can a skill be? At what point? I don't know. It's a very like hard thing to quantify, I guess. But when is it specific enough that it can be pulled and used in different places? And when is it, maybe a big skill? And go ahead.
I've been thinking that it's like one idea I've had is like one idea I came to, and this is probably true of everything, but not just APIs. But I kind of thought like, well, if you're in and maybe I think you're getting at like how complicated of a program could it create, and then how where's it going to stumble in the building blocks of what it could create. So where would you give it a task and it couldn't do it? And like one thought I had is just, anything with kind of well-known APIs where that's its original building block that it might know is quite powerful because it's part of the model itself. There's some knowledge base around that. So you're starting, and I think that's kind of the case here. You're maybe starting with stuff it kind of knows or knows in some way based upon its worldview or world knowledge. I think it's probably, it's probably need to start at those bricks, and then I don't know where it would break as you're trying to build up the hierarchy. Like there's probably too complex of a program to create, where like simple tree hierarchies like this is right here, probably slightly easier to build and a good area to focus. You build iron, you can use a sword without, you can use iron to build a sword. It's simple hierarchy and
with very clear rules and numeric recipes, like
but who knows
And I think the question, like the question is like, if I had to take it back to code generation, like what's small enough as a skill set, what's big enough, how does it know what it can use together, are all really interesting questions, right? Because there's
I don't know that there's a threshold. I think it becomes an interplay between the curriculum that's generating the skills or that's generating the tasks, the component that's generating the skills, and the piece that we haven't really talked about, which is I'm blanking on what they call it, but the self-feedback mechanism, where
the critique,
self-verification, where they determine if they did the task well enough, which I thought was particularly interesting in that it builds in this notion that it's not a binary yes or no necessarily, you did it well enough, and it doesn't come, sometimes it comes explicitly out of the environment, like your program might crash and then you did not do it well enough. But just like with a human skill, if you were practicing doing a backflip, you might do a backflip but you stumble on the landing, and like, did you do it well enough? You might feel like yes, but a professional gymnast might feel like no. And so I think that the generality and specificity, I think it's not just enough to analyze the code that gets generated, but if you don't have an ability to verify that, then you have surpassed the degree of complexity for which this is going to work.
Good point. The
iteration here is interesting. Like we talked about this, but like it I think you'll see this in code gen a lot. I've been seeing it all over the place, which is when you have GPT-4 creating code for you, don't do it zero shot. Like have some or do it, if you do zero, like if you're doing zero shot, then have some feedback and like some ability to iterate on it. Like don't just take the one thing it comes out. You probably have to run it, get some feedback, iterate on that based upon that feedback, and it does a pretty good job at that. And I think this is just another clear example of that. And this example, it even knew it couldn't use or create the thing it was trying to create. so this is kind of the iterative prompting mechanism that we were just talking about there, with some kind of self-verification of checking test success, which Michael, you were talking about on the critique side. And this is some examples of what it looks like.
Yeah. Yeah, actually, if you go up just a little bit, Jason.
Yeah.
So I thought this part was cool. So they actually said, okay, there's 3 types of feedback that they looked at. Self-verification was obviously, we'll get into that. There's kind of like this environment feedback. Like, I can't use this skill in this specific scenario because of whatever reason. So maybe I'm trying to make a fire, but it's too windy, right? So there's kind of like environmental feedback. And then there's execution errors, where it's a little bit more about the tactical code, bug related issues. And then this one, which is more around self-verification for checking the task success. So it's then at each new task, instantiating another GPT-4 agent, checking if the task was done or not, and kind of like why, why, like the reasoning, I guess, on the task.
Yeah.
And so if we go to like one of the examples, like maybe we can read one of the wrong ones. To craft a spyglass, you need 2 copper ingots and 1 amethyst shard. Wow, I haven't played Minecraft. You have 3 copper ingots, but you don't have any amethyst shards. False. Find and mine an amethyst shard underground. Okay, so that wasn't a great example because I have no idea what the context is, but go ahead.
I think the point is here is I was looking at this in the code base, which we'll kind of show in a sec with the prompts, but the critique, in order to critique it, you kind of need to know the world. And that you're at, so there is a key point here. In order for this feedback loop to actually work, you still need the LLM to have some worldview and to give you this critique and feedback. Because this doesn't come from anywhere else but the LLM itself.
Except for the minor amount of additional context that's provided by the Mind Player API.
That's true. That's true. Yeah, that's an additional piece. Yeah.
But you're right.
You might be right. Like that actually, that is one piece that you are getting feedback on too.
It's an interesting balance. I mean, I think it comes back to your original question earlier about curriculum for games that's not built into the world. Yeah,
it's a good point. That I thought I'd show, so let's just see if we're kind of okay. I thought I'd do one thing real quick, just look at
nice.
Let's do a paper read with actual we'll do prompts first. But like just getting an idea of what these look like. So the prompts are in here within the Voyager code base, kind of what this looks like. This is an example of like the skill, like what do you like when you're asking to write a function, what does it look like? Pretty good boilerplate here for anyone doing stuff to probably write functions. Not a ton outside of just help me write a function here. So I thought that was pretty basic. Curriculum's much more detailed. Ask a mentor, please verify. This is kind of giving you the setup to try to get good tasks out.
Between that and the amount of Minecraft world information that seems clearly there from just me poking around, yeah, it makes a lot of sense.
Yeah. A little bit on the critique, critic and critique. So what goes, your assistant assessment, you're required to evaluate. So you do get this information, you are getting some feedback from the game. And it gives you an example, JSON response. But these are useful to kind of go through and get an idea. I mean, if you're going to build your own or do anything around trying this stuff out, and then they obviously have the agents in here too. I think the one note I did see in here is there were some kind of like edge cases where they did have to, you know, it's not like completely generic. There were some edge cases where maybe it wasn't this one curriculum, where they did have to encode some of the Minecraft world into the code base itself. Not surprising, but I just kind of noticed, you know, slightly little bits of kind of initial state or state zero and kind of in this agent, the curriculum agent, to deal with kind of the kind of cold start stuff.
I wonder if some of that was to get around the limitations that they brought up, where well, they had a specific one.
But I'll go back to the paper here. But didn't want to give a taste for what's there. And
yeah, for instance, GPT-4 tends to use cobblestone as a fuel input, despite being an invalid fuel source in the game. Made me the phrasing there made me think that was a frequent error, that it would, you know, put cobblestones in it. And so I wonder how much of the edge case programming you're seeing is not to deal with places where it had encoded in its parameters just incorrect information about the world.
Yeah, absolutely. I think, I mean, some of the more interesting things, to be honest, in the code and what they did there, and that, or at least in the release, there's a lot of like a lot of magic in the prompts, which is funny. I spent a lot of time looking at those, and you know, there's getting all the stuff to work is one thing, but you know, some of the magic comes there. It's probably the stuff we'll be touching a lot day to day too.
One other thing that I was thinking about while reading this was the meta training and evaluation cycle. I started to think about the accumulation of the skill library as a training phase, and it's the slower phase. You're going to make mistakes during the iterative prompting process. The code proposed as skills won't be good enough, and you're not going to be able to deal with tasks as they happen because you don't have skills for it yet. And they address a little bit of the generalization of those skills in the zero shot case, but where you take an agent that's not trying to iteratively prompt and build new skills, but Jason, you brought it up a little bit and you have it highlighted here, but just plugging an existing skill library into a more standard agent, which just receives tasks, decomposes them into subtasks, and then goes to act on them. But it has this bank of things to act on. And that would be kind of like the inference time for these in context learned agents.
Yeah.
I do wonder if those will be fast enough for real game playing soon. They have the code up. I wanted to get it running, but I didn't have time before this morning. But yeah, I'm quite curious to see how it does in a real-time setting.
Yeah, I thought this was fascinating. Like the fact that Auto GPT with the skill library actually improved it too. Like, you know, it's sort of like a whole set of LLMs that just build skill libraries over time. Are those skill libraries like code we have? I mean, it just was like fascinating to me. Like where does this go? One LLM use another LLM skill library.
I feel like there's a lot of, I mean, one of the things they talked about in the paper was cost.
Yeah.
It's an expensive thing to run.
Yeah.
Every step of the way, there's some LLM verifying and checking and thinking and pulling, retrieving. Like this would be really expensive to actually run, I feel like, today.
I don't know about you, like I feel like everything we're doing is like LLM spaghetti a little bit. Like I'm calling another LLM to check this LLM's response, and like it doesn't matter what you're doing, you're probably doing LLM spaghetti. So at some point, Yeah, it's somewhat,
Yeah.
I don't know if we ever get out of it. You know, maybe we have less checks eventually, but
So early in all of this.
yeah,
I think that there's a degree of people just trying stuff and seeing what works. And
yeah,
we're beginning to see patterns. The use of vector databases and indexing complex structures via
yeah,
their embeddings is just going to keep coming up. In context learning, I think, is just going to keep coming up.
yeah.
But I wonder how much we're going to be able to leverage LLMs up front and then remove them after the fact. I think that's kind of where I started to go with this, like training time. You use the LLM to build up your skill library, but then at playing time, can you remove a large amount of that cost by just grabbing pre-crafted skills? And it's a much smaller natural language problem to decompose your input task into the subtasks that you use to index your skill library.
Yeah.
Can you bring that cost down to, you know, run on the edge?
If I were to, I mean, this is, this is kind of, it's always hypothetical. And I feel like with this stuff, I like to actually have real data. But if you're going to imagine their skill libraries, and imagine this was out in the wild, what do you think from an observability perspective? What does observability look like on these? And what are the pain points we think we're going to have as we build this? Any, you know, thoughts or insights as we all are thinking about it? It's probably
Well,
a lot. It looks
yeah.
quite different than the infra side.
I don't know if you guys saw, but it actually scroll down to the report section of the paper, limitations and future work. They talked about, can we just read the section on hallucinations out? That was I mean, I feel like the self-verification was interesting because they're kind of running a little bit of checks and observability in the process before they kick off the actual task. So observability wasn't just this, let me wait until the final, it was almost like a part of the task process. But so the hallucination section, okay, cool. Love that it's highlighted on yours too. The automatic curriculum occasionally proposes unachievable tasks. For example, it may ask the agent to craft a copper sword or copper chest plate, which are items that do not exist within the game. Hallucinations also occur during the code generation process. For instance, GPT-4 tends to use cobblestone as a fuel input, despite being an invalid fuel source in the game. Additionally, it may call functions absent in the provided control primitive APIs, leading to code execution errors. We're confident improvements in the GPT API models, as well as novel techniques for fine-tuning open source LLM models, will overcome those limitations in the future. This is really interesting, right? There's kind of like a couple different places where there's hallucinations. It's, you know, the agent level, the code generation process, and then even in the control primitive APIs, like there's kind of like a couple different places where they're calling an LLM, and then in that spot it's hallucinating and probably has some downstream impact. Could you know, if you just score at the end, like Minecraft's a tough one because there's not like this end goal that you're kind of pushing towards. I don't know, maybe mining a diamond, I'm not sure. But you know, if there's some way to almost like score, well, did it build the table? Would you consider this a good table? Like almost like scoring at the end of it, but then you'd want to trace it back down to what part of the agent did it actually break in? Where did it actually hallucinate? So it's like a little bit more complex than just looking at the final result.
I think this is also, I kind of feel like there's exactly that. Like there's two major problems right now. Like two major problems I kind of see that I categorize things into around this. Like one is hallucinations we've seen, like if you give it bad context. So you embed something, you return something, and you put that into the context and it's kind of wrong. Like that tends to cause a lot of problems, but that feels somewhat fixable. Like you probably could fix not putting the right, you know, as much as you can, or you could improve that. But then there's like stuff where just, I don't know if this cobblestone, like I doubt they're putting cobblestone into the context, like it's just thinks cobblestone's part of the game or part of something you can use. And it's like humans can make a small mistake and easily correct it. And I think with LLMs, like we're kind of having to work around where you can't correct these tiny things that they have. You have to do it in the context window, and you can't do it globally. And you've got to remember in the context window to keep telling it you can't use cobblestone. And maybe that's the future of this. You just collect the small skills like that, or the small feedback notes like that. But I think tracking these, keeping track of all this. We have a whole, I'll give a plug for the Llama Index search and retrieval event we have tonight. We're doing how to troubleshoot search and retrieval, how to evaluate it. Probably some of the most groundbreaking, really good groundbreaking work on analyzing search and retrieval, at least visualizing it, troubleshooting it in real world situations. We've done it on a bunch of production data, and we have some examples with real data. And I think that this continues to be something that is going to be a challenge. It's going to be hard to understand, hard to track when it occurs, hard to give feedback on like what to do to fix it. You're right. Like it's going to continue to be like one of the bigger challenges here is tracking these down and helping troubleshoot when it occurs and what you should do to modify.
I expect we'll also see observability in modules. So what we're calling one thing as Voyager is actually the combination of several complex things. And so I would expect that you would have observability tools specific to code generator modules. They discuss a little bit of the prior work around code generation and execution, techniques like intermediate execution and guided program search. So I think there will be some classical techniques that are applied to the submodules, new techniques applied to the search and retrieval components, probably specific observability. So like Minecraft specific stuff that is just, task specific, so I guess the word I was looking for. But yeah, I think you're going to see several different styles of observability from a space like this.
And we're in the early stages too. It's just going to get more complex. Any other this? I thought this was kind of interesting. Did you all catch this? Like, how could humans be in the loop? Where would you put a human in the loop in terms of controlling the success or outcome?
This reminded me a little bit of the baby dev or small dev, small dev. In terms of I find the phrase hallucinations interesting for natural language models, but I think these techniques are interesting because we're using them in a sense creatively to generate something from nothing. So hallucinations might actually be good for you in the generating of code space, not hallucinations like making up API calls, but hallucinations like creative ideas that weren't present in your. I think there's a thin line between, or a blurry line between a hallucination that's wrong and just what these models were trained to do.
Yeah.
So the idea that you could plug a human in to either combine those outputs or to guide those outputs, I think is highly realistic, especially as you start to think of skill libraries as generated code and the evolution of code bases as a thing that is a cooperative act between a human maintainer and a natural language model junior dev, if you want to call them
that. All right. I'll like. It's hard to believe. I think like a year or two ago, we would have never thought that was possible, but it's amazing we're saying today. The human as a critic, like that, critiquing the responses and being able to give that feedback. That seems like one of the harder things to do, to give that feedback. It sounds like in some areas here where it can't perceive the environment that well, or has missing some some ability to perceive the environment, like that was critical. And then the curriculum layout, like we were talking about in the beginning, that world model view that you kind of have to have in your model. And if you don't have, maybe it's not complete, or maybe it doesn't know it, or, you know, it's you could potentially provide some of that. And you can imagine as these get bigger and more amazing, I think the vision is to be able to have them build their own world model, you know, dynamically. So, or add on to the world model they have. So, I think the interesting, like, two places where humans can come into the loop and actually improve or fix. Yeah, do you have any other things here? I mean, there's a section, I thought these, you know, that the results were pretty impressive. Really
The results were impressive, though they state it themselves. There's not really anything that they can compare it to directly, and so their comparisons to existing algorithms are, I think you just have to take it face value, because they actually had to reinterpret, or in some cases fully re-implement the technique.
Mm-hmm.
It's up to them how well it worked.
Yeah.
But just this method of embodying an agent that that normally can only output language using code, I think is fascinating. That
Cool.
Code through an index skill library is the way you can take a language model and let it interact with the world.
Yeah. I mean, that was amazing with this.
Cool.
Well, awesome.
Looks like we're at time. Thank you all so much for joining, and, you know, let us know paper recommendations for next week. If you want to suggest any. Awesome. Thanks all.